another live of online biology tutorials. In this live of today, I will be reading chapter 5 Changes Around Us, Physical and Chemical. This fifth chapter is taken from the Curiosity Book of Science, applicable for class 7. So, as the screen is clear to you, let's begin with the reading of Class 7 Science Curiosity Book, Chapter number 5 Changes Around Us, Physical and Chemical. So, this boy is thinking I placed the cube of ice here half an hour ago. It has now become water. And this girl is thinking a bud that I saw yesterday on this rose plant has become a flower today. Yet another girl, the bottle containing cold water is not cold anymore. And this boy, yesterday I saw some brown spots on a banana, but today it has more brown spots and a strong smell. These students are describing some changes. What kind of changes are they talking about? Let's come to the activity 5.1. Let us think and reflect. You might have observed various changes happening around you. Some of them are listed in Table 5.1. You may notice that something is changing in each case. Take a moment to reflect on the changes in each case. Record your observations in Table 5.1. So the changes are melting ice cubes, chopping vegetables, boiling water, making popcorn from corn, cutting a piece of paper, adding beetroot extract to water, burning wood, drying wet clothes, making small balls of dough, rolling small balls of dough into chapatis, or there could be some other as well. You might have noticed that these changes could be in the size, shape, smell, or other property of the substance or object. Can you think of some other changes that might happen in your surroundings? Make a list of those changes too. We observe the changes occurring around us with the help of our senses of sight, smell, touch, hearing, and taste. Can we arrange these changes into categories? Let us try to answer this question. 5.1. A substance may change in appearance but remains the same. Activity 5.2. Let us create and discuss. Creating some objects with paper. Take a few sheets of paper and fold them to create new objects. So these are the objects being made for you. Do you get the same paper back when you unfold these objects? Playing with a balloon. Take a balloon and inflate it. Now loosen your grip and let the air escape out. Do you get the uninflated balloon black? Take another balloon, inflate it, and grip the opening tightly. Now prick it with the pin. Caution, be careful while using a pin. What happens? Will you be able to get the uninflated balloon back? So these are the examples that are being listed for you so that you can come up and find it out which amongst them are the physical changes and which among them are the chemical changes. Crushing a piece of chalk. Crush a small piece of chalk into powder. Can you get the chalk piece back from the powder? Is there any similarity in the changes listed in A, B, and C? During all these changes, materials such as the paper and the rubber sheet of the balloon and the chalk remain the same, though their appearances, shape, or size may have changed. You may also recall from grade 6 science textbook Curiosity that water can exist in different states. It could be solid, liquid, and gas and can change from one state to another. In all these cases, although we observe a change in the appearance, no new substances form. Such changes in which only physical properties like shape, size, and state of substances change, these are known as the physical changes. Let us explore a different type of a change. A substance may change in appearance and not remain the same. Activity 5.3. Let us explore. Take two glass tumblers or small transparent bottles, mark them A and B. Fill 1/4 of glass tumbler A with tap water and 1/4 of glass tumbler B with the lime water. Now blow air, exhale into each glass tumbler one at a time using separate straws as shown to you in figure 5.2 and observe them. Caution, do not suck the water or lime water while doing this. Do you notice any change in glass tumbler A? Blowing of air into the water creates bubbles only, and there is no change in the appearance of the water. In glass tumbler B, blowing air into the lime water creates bubbles and turns the lime water milky or cloudy. If we leave it for some time, a white substance settles at the bottom of the glass tumbler, indicating something new has formed. Such changes in which one or more new substances are being formed called the chemical changes. New substances are formed through a process called chemical change. In this case, carbon dioxide from the air you breathe out, exhale, reacts with the lime water and forms a new white colored substance called calcium carbonate that is insoluble in the water. Therefore, the liquid in the bottle appears milky. Along with this, a small amount of water is also formed. This formation of a new substance indicates a chemical change. The chemical reaction involved in this change can be represented in short form as a chemical reaction. So here in words, the chemical reaction has been written calcium hydroxide, carbon dioxide will be reacting together and what will be formed? Calcium carbonate along with them water is released. One of the viewer is hearing to this live. I would request that in case you know the chemical formula of calcium hydroxide and carbon dioxide, please do write it in the chat. The turning of lime water milky is also used as a test for carbon dioxide. Let us explore this with another activity using some substances from our kitchen. Activity 5.4. Let us experiment. Take a teaspoon of vinegar or lime juice in a test tube. Add a pinch of baking soda, sodium hydrogen carbonate to it. What do you observe? You would hear a fizzing, bubbling sound and see the gas bubbles forming. Pass this gas through freshly prepared lime water kept in another test tube as shown in figure 5.3a. This one. What do you observe? The lime water turns milky. What do you infer about the gas formed by mixing vinegar and baking soda? This indicates that the gas formed is carbon dioxide. This activity can also be performed using two small used bottles instead of test tubes and a flexible straw as shown in figure 5.3b. This one. Since a new substance, carbon dioxide, is formed in this reaction, we say that a chemical change has occurred here as well. It can be represented as vinegar plus baking soda will be forming carbon dioxide and other substances. Repeat the above activity using baking soda and water. Do you observe any bubble formation? Is this a physical or a chemical change? So in case new components are formed in the chemical reaction, it is always a chemical change. Some other processes involving chemical changes. Rusting, we just read in the previous chapter. In the rusting of iron, which you have studied in the chapter The Word of Metals and Non-Metals, a new brown colored substance called rust is formed. Thus, rusting is also a chemical change because it involves the formation of a new substance, which is iron oxide. And iron oxide is always formed when Fe or iron reacts with oxygen and water. 5.3.2 combustion. Let us recall the burning of a magnesium ribbon. So magnesium ribbon, when it burns, it produces a dazzling white color. Learned in the chapter The Word of Metals and Non-Metals, can you predict if this is a physical or a chemical change? When the magnesium ribbon is burnt, a new substance called magnesium oxide is formed. So the burning of magnesium ribbon also involves a chemical change. We observe that heat and light are also produced along with the formation of new substance in this reaction. The burning of magnesium ribbon can be represented as magnesium plus oxygen will be forming magnesium oxide plus heat and light. Remember, students, all the reactions in which heat is written on this side along with the products, they are exothermic. EXO, exothermic. And if heat is written this side along with the reactants, then they are endothermic. Endothermic means the reactant will be converted into products after taking heat. And if the reaction is producing energy, it is always exothermic like this. A chemical reaction in which a substance reacts with oxygen and produces heat or light is called combustion. Substances that undergo combustion reactions are called combustible substances. For example, wood, paper, cotton, kerosene, etc. are combustible substances. Let us find out whether the presence of oxygen is essential for combustion or not. Activity 5.5. Let us investigate. Place two identical candles on two separate petri dishes and light them. Cover one of these with a glass tumbler as shown in figure 5.6. What happens to the candle flames in the two cases? So we observe that the candle that was not covered continues to burn, whereas the candle that was covered with a glass tumbler stops burning after some time. Why does this happen? Since the candle covered by a glass tumbler does not have a continuous supply of air, the flame gets extinguished soon. The cover the glass, the supply of oxygen is cut. That is why it will not burn continuously. This can be confirmed by the presence of carbon dioxide in the glass tumbler inverted on the candle. How can you test the presence of carbon dioxide gas? Remember, you know, combustion will not happen in case oxygen is not there, right? So you can test carbon dioxide gas by adding a small amount of lime water in the petri dish. You will notice that it turns milky. This carbon dioxide was formed by the carbon required for combustion. Very, very important. See that if any place has caught fire, fire extinguishers are used. Fire extinguishers, they have CO2 in them, and once CO2 is sprayed, it cuts oxygen. Science and society. If a person clothes catches fire, what is the best way to extinguish the fire? Wrap a blanket or cloth around the person. This cuts off the supply of oxygen and the fire gets extinguished. Caution, synthetic blanket or cloths should never be used or put out a fire for putting out a fire, as these can melt and stick to the skin. This is very important thing. So hard blanket can be used to cover a person, because of which the supply of oxygen will be cut and fire will stop automatically. Fascinating facts, nature's wonders. You might have seen some insects emitting the light in the garden or a field in late evenings. These insects are called fireflies, and their light is produced by the chemical change. This type of light produced without heat in living organisms is called bioluminescence. Bio means living, and luminescence means the power of emitting the light. Is the presence of air enough for combustion? We learned about that combustible substances and oxygen are necessary for combustion. We also know that paper is combustible substance, but we can keep it in the air for any length of time without it catching fire. What else is needed to start combustion? Let us learn about this. Activity 5.6. Let us investigate. Perform this activity under the supervision of your teacher or an adult. Hold a piece of paper with a pair of tongs and bring it a lighted matchstick to it. It quickly catches fire. Do we say that we need a fire to start the burning process? Take another piece of paper using a magnifying glass. Focus the sun rays to make the smallest and brightest spot on a paper, as shown to you in 5.7a. This one, hold it for some time. What do you observe? We observe that paper starts to emit smoke and then catches fire. Means here you can see that it has caught the fire now. Thus, we find that a substance can burn even without fire. How do we explain this change? Focusing sun rays on the paper heats it. The temperature of the paper increases with time. After some time, the paper becomes so hot that it starts burning. This minimum temperature at which a substance starts fire is called ignition temperature. Since the temperature of the lighted matchstick was already higher than the ignition temperature of the paper, it caught fire almost immediately. So we can conclude that for the combustion process to occur, there are three requirements. A combustible substance, also called fuel, is required, oxygen is required, and heat that allows the fuel to reach its ignition point or ignition temperature is also required. Can physical and chemical changes occur in the same process? What changes takes place when a candle is lit? Let us explore. Activity 5.7. Think, pair, and then you have to share. Look at figure 5.9. Analyze what students are discussing about the burning candle. What do you think? The wax melts and evaporates. I think the wax burns and a new substance are formed. Maybe the wick draws up the liquid wax. Maybe wax melts, flows, and solidifies in different shapes. So, five students are sitting and discussing the burning of the candle. The wax of the candle melts, it carried up the wick and evaporates due to the heat of the flame. The vapor of wax burns to produce a flame. The melting of wax, its solidification and evaporation are physical changes. The burning of vapor, on the other hand, is a chemical change. This shows that the burning of candle involves both physical and chemical change. Make sure you should remember this experiment till higher classes. No, a scientist. The candle you just observed has long been an object of curiosity for several scientists, including Michael Faraday, who made significant contributions to several areas of science. In the 19th century, Faraday delivered a series of lectures called Chemical History of a Candle. Faraday believed that the candle was the perfect object to introduce scientific study. Through it, he discussed differences between various physical and chemical processes like melting, vaporization, and combustion. 5.5 are changes permanent. Once something has undergone a change, can we get it back in the original form? Activity 5.8. Let us think. Think again about all the changes that we have discussed or talked about so far. In which of these can we get back the object or substance in the form we started with? Record your observations. So they have asked you to see for all these objects. Melting ice cubes, the original state can be brought back. Yes, it can be. Chopping vegetables cannot be brought back to their own shape. Boiling water can be brought back again to the same condition. Making popcorn from the corn, no. Once the maize is popped, it cannot revert. Returning to the original object or substance with which we started shows that the changes we brought can be reversed. For example, when ice melts, it can be refrozen into ice. Similarly, when water evaporates, it can be condensed back to the liquid water. However, some changes cannot be reversed since we cannot get the original object or the substance back after the change. For example, chopped vegetables cannot return to their original size and shape, and making popcorn cannot go back to its original form. Thus, changes around us could be grouped into those that can be reversed and those that cannot be reversed. 5.6 are all changes desirable. Many useful changes happen in our daily life. For example, the changes of milk into curd, ripening of fruits, cutting of fruits, and ripening of fruits, cutting of fruits, and cooking of food. All these are desirable changes. Can you think of some other desirable changes happening around you? On the other hand, some changes may be undesirable, such as the rusting of iron or the decay of food during its storage. A change that is undesirable in some situations may be desirable in other situations. For example, decomposition of food can be very useful in converting food waste into compost. Some changes occurring over the years due to human activity can have a long term environmental effect or impact. For example, the increased consumption of fuels in cars, trains, aeroplanes, etc., is increasing the amount of carbon dioxide in the atmosphere. Drying of paint on walls, doors, furniture, etc., it is releasing many substances through evaporation, causing atmospheric pollution. All the students who are hearing to this live, if you are in class 7, do consider subscribing to my channel because I have a lot of content for ninth and 10th as well. 5.7. Some slow natural changes, weathering of rocks. Have you seen heaps of sand, soil, and stones lying at the base of mountains as shown in figure 5.10a? This one. These are called sediments. How have these formed? These are formed by physical changes that break up the large rocks into smaller pieces. Temperature changes due to climatic conditions, growing roots of trees, and even freezing of water within the cracks in the rocks can cause them to break. Water or chemicals present in the water can also react with the rocks and cause chemical change in their composition. An example of such chemical change is shown in figure 1.0b, this one. Here an originally black colored rock called the basalt, which contains iron, has chemically changed to produce a red colored layer. The Red color is the result of iron oxide produced when the rock surface was exposed for a long time to water or air containing water vapor. These physical and chemical changes in the rocks are collectively called weathering, which eventually leads to the formation of soil. So, weathering is the process in which rocks are being broken into smaller pieces. What is erosion now? Have you noticed fine sand collecting on riverbeds or in lakes? This sand is formed when rock pebbles, soil, and sediments are broken down and moved from one location to another by natural forces like wind and flowing water. This process is called erosion. Erosion during a landslide is an example of a physical change. River rocks and pebbles often appear smoother due to the constant erosion caused by the flowing of water. When the speed of the water or wind decreases, such as in an ocean or a lake, the material transported during erosion settles down at the bottom. These sediments harden over time and become new rocks. Most of these changes take place over thousands of years and cannot be reversed. Next, in a nutshell, a physical change is one in which a substance or object undergoes a change in its physical properties and no new substance is formed. A chemical change is one in which one or more new substances are formed. It involves a chemical reaction and can be represented by a chemical equation. Combustion, cooking, and rusting are examples of chemical changes. Substances that undergo combustion are combustible substances. Heat and or light are given out during combustion. The lowest temperature at which a substance can catch fire is called its ignition temperature. Some changes can be reversed and some cannot be, and some changes are desirable and some are not. Rocks undergo physical and chemical changes due to the weathering process, and this forms the soil. Erosion caused by flowing water and wind is a physical change. So these are the questions. In case you want to attempt all these questions, you can pause the video here. This is the second page for the questions to be attempted. I hope the full screen is visible now. This is another page, question page. In case you want to attempt this page for the physical and chemical changes, you can pause the video and you can go ahead. Now, this is the last page of the questions. So, with this, students, I am done with the reading of chapter 5 Changes Around Us, Physical and Chemical. In case this video was helpful, do consider a like, hitting a like button, and do share it with your friends so that they could also avail the benefit. A playlist has already been uploaded for the first 4 chapters. Do consider subscribing. We have a lot more for you. See you in next video. Stay connected. Thank you.